Okay, hey everybody. I'm going to go ahead and do lesson 2.1a and 2.1b again. I did this morning during class. Some of you may or may not have been able to participate in the Zoom. Zoom was flaking out big time this morning, and I think there was a nationwide outage because I got an email from COD saying that things weren't quite working out. Like I think my Zoom dropped out on me once or twice. People weren't able to get on. So I'm going to go ahead and just redo this entire lesson for 2.1a, 2.1b. I'm going to go ahead and post a bunch of lessons here and kind of keep you up to date on what's going on. So yeah, I just came back to COD and my kids are at swim team in the area. So I thought I'd come back here and I have some quiet area to make some videos. So I'm going to go ahead and start this. Now, the first part of the lesson just kind of defines what an exponential expression is. It's basically just an expression. I put in there, duh, but expression that involves exponents. And most importantly, it's an expression where the base part, like instead of like 5 squared or 17 to the 4th power or something like that, the base is a variable. It's like an X or an N or an A or whatever letter you can imagine. Be to like X to the 3rd, Y cubed. That's what we're talking about. The base is a variable base. It's more an algebraic type of exponent that we're talking about. Okay. Let's go ahead and, like I said, you can probably pause the video and just copy that down as we're doing it. If you want, it's up to you. For number 1 through 5, let's kind of go through these. These are basically kind of review, but we'll just go through them either way. So the first one there, we've got 3 to the 4th power. That just means 3, and it just says identify the base. We don't have to do this every time, but 3 is the base and 4 is the exponents. The whole thing is called the power, which is kind of confusing, but I try to avoid that whole language. But 3 to the 4th power, we've got, which just, if we expand it out, it means 3 times 3 times 3 times 3, which equals 3,003. No, it doesn't equal 3,000. It equals 81. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. I think that's what it is. All right. And then for number 2, we're going to pay attention to the fact that we have an even power. And for number 3, there's no parentheses versus number 2 that does have parentheses. So when there are parentheses, we pay attention to the fact that it's even. I should have started off with that. But you've got negative 3 to the 4th power. Now, since it's an even power, that means it's going to come out as positive. It's going to come out as positive. So it's the same thing as before. It's still going to be 81. And then when there are no parentheses around the base, this value right here does not have anything grouping it. It's just that negative is kind of just there floating in front of that base. That means it's always negative. Doesn't matter if it's an even power or an odd power, it's going to be negative no matter which way you look at it. All right, same thing with number 4. That's going to be negative 25. Okay. I think there's one. Is there one more? Yeah, there is. All right, number 5. This one is in parentheses, and it has a odd exponent. Therefore, this should come out negative. So negative 5 times negative 5 times negative 5. Well, 5 times 5 times 5. Well, let's just do this little by little. 5 times 5 is 25. And then 25 times 5 is 125. And don't forget the negative because it's have an odd power. Okay. So that's that. All right. All right. So the first property rule that we're going to talk about is called the product rule. Product rule. And there's the thing I was reminding, I think I talked about this morning during the regular class time, which was, for the product rule, you want to add the powers of the exponents. And the most important part here is that the bases are like. You want to do that with like bases. And the thing I was going to say about all these rules for exponents is that there's a lot. It gets a little bit nutty. So it's good that you kind of have all this. Obviously, you're writing all this down, and you want to kind of keep it all organized. But I mean, the first rule is pretty easy, and the rules by themselves aren't difficult necessarily, but it's when they all kind of stack one on top of the other, and you're kind of overlapping rules and different properties and things like that, that it gets confusing. So I think the best bet with doing these kind of problems is just to practice them. Just kind of get used. Just the more you do them, the better you're going to be. Now, like I said, for this particular property, all you have to do is add the powers. That's all you got to do. Okay, so for number six, we're going to, I just spoiled that for you, but whatever. We've got, for number 6, we've got 5 squared and we have 5. Now, if there's no exponent, by default, you can imagine that there's a 1 there, okay? So all we have to do is add the powers. All we have to do is add the powers. So it's going to be 5 to the, you don't have to do this, but I'm just going to write it out. 2 plus 1 power, which is 3, 5 cubed. And then it says find the product, which means we're going to work it out, which is 125. Okay, so that's number 6. Okay, so that way works. And the other thing too is that if I end up showing you the wrong way to do this, which I tend to do a lot, if you do this wrong, which a lot of people think is the right way, the okay way to do it, some people are like, well, isn't it okay if I just multiply the bases, like 5 times 5, which makes 25, and then just attach on the exponent? And that doesn't work, because you can obviously see that 25 to the third power is not 125. That 25 to the third power is 25 times 25 times 25. 25 times 25, I know off the top of my head, is 625. And then 625 times 25, I think, is 5,225, 5,000. It's one of those, like 5,000-ish. It's in that range. So yeah, not even close to 125. So make sure, you can't do it that way. You've got to just work with the exponents first. And that's the general rule for order of operations for PEMDAS, which is exponents come before multiplication for sure. All right, let's go right below there. The second, number 6, I guess. All right, so for that one, just going to add the powers up. All I got to do is 4 plus 9, which is 49. No, it's not. It's 13. Okay, so y to the 13th power. And as far as we can go, we can't do any more with that. All right, going on to number 7. Now, what you want to do here is it's important that you kind of compartmentalize rules. So when it comes to the coefficients, like -4 is a coefficient and -10 is a coefficient, we multiply those like we normally would. Or if we're adding like terms, we would add those or subtract those the way we normally would. So we're going to treat those like we do any other number. So we're going to do -4 times -10. -4 times -10 is, I was going to write negative, is positive 40. It is positive 40 right there. And then when it comes to the exponents, we're going to use the exponent rule, the product rule, which means we're going to add those powers. We're going to add them up. So we're going to add x to the 5th, x to the 8th, which is 13. So there you go. So that is our solution. It's worth noting that when you do these kind of problems, that you get an answer that looks like there's more work to be done. I think that's sometimes a common theme in algebra, which is like you're done with a problem, but it looks like, and it's sometimes worrisome, I know, to some people, because you guys have anxiety to begin with for math, but just kind of trust your math here, and that that your answer is it. Because it looks like I said, it looks like we have more to do. But I mean, if we knew what x was, perhaps if we had to evaluate for x, we can solve it. But yeah, as far as we're concerned, we don't need to do anything more with that. All right, and then for 8, I gave it away already. That's d to the 12th. I think that's, I tried to erase all my notes I wrote this morning. I must have forgot to write that one down. But yeah, that's just a result of doing 1 plus 7. You know, just add those powers up. 1 plus 7 plus 4. 1 plus 7 is 8. 8 plus 4 is 12. And that's it. D to the 12th is good as we can get. Okay, moving on to the next page of your notes. Moving on to the next page, we've got the basic power rule. All right, and then I kind of put the notes kind of above there, but that's also called another name for that is called a power to a power or power of a power. And when this occurs, you can kind of tell the difference between a product of powers and a power to a power, because they sound exactly the same. I get it, but a power to a power is where you have, just like a number 6. I know they're not all going to look like this, but on number 6, notice how we have a 6 here, and we have a 3 there. You have that, and like those exponents are one after the other. Like one is, sometimes it's raised up a little higher, but I don't want you to get hung up on like whether it's a little bit higher or a little bit lower. But that is typically what a power to a power problem is going to look like. You've got something like that. So what you do in this instance is you multiply the powers. We're not going to add 6 plus 3. We could think of it as addition, but I'll show you that in just a second. But we're just going to do 6 times 3, which is going to make 4 to the 18th power. All right, now we could work that out and figure out what 4 times 4 times 4 times 4 times 4, but that's going to be, that's probably not even going to fit on your calculator. It's going to be a big, big number. So I would just leave it in exponential form. 4 to the 18th is fine with me. I don't care. Or if you want to think of it as product rule, think about expanding this. This one says cubed. So we're going to do 4 to the 6 times itself, right? Times itself 3 times. So 4 to the 6 times 4 to the 6 times 4 to the 6. Like that. And then you can kind of see how the product rule, 6 plus 6 plus 6, ends up working just exactly the same way for this one. Okay, so you got 4 to 6, 4 to 6, 4 to 6, which is still 4 to the 18th. Either way you cut it. Okay. All right, number 7 is a textbook power to a power. So just do 2 times 5, which is going to make 10. So that's going to be m to the 10th power. M to the 10th. All right, sorry if I'm pretty through that one. That one's not too tough of a problem. All right, number 8, let me slow down for a second here. And let's focus in on the innermost part of the grouping there, of the parentheses. And notice that you have a negative base in parentheses, and you have an even exponent. Okay, so we're going to use that rule that we know about even exponents with a negative base, which means that if the base is negative and you have an even power or exponent, it's going to come out to be positive. It's going to become positive. So if we simplify that, I know it doesn't seem like we're simplifying it much, but if we simplify that, that becomes q to the 8th, just, positive q. You don't have to put a positive sign there, but it's positive q to the 8th, okay, to the power of 7. So now now we're going to look at it as a power to a power, and this time around, now there's no negative. We don't really need to worry about the negative, so we're just going to worry about 8 times 7. We're just going to multiply that, and that's going to be q to the 56th power. That's it. Isn't that easy? I know, like when I talk about these problems, it makes it look easy. And I think for you, the important part is that you practice it. This is getting the practice in is the important part. Okay. All right. For number 6. Now what's going on here? Well, you know what? Let's just go ahead and talk about this. For number 6 and all the subsequent problems after that, you're going to notice that a lot of these, we have parentheses, and then outside of the parentheses, there's a power, there's an exponent. okay? And the way you want to treat that is that, and I hate to use the word distribute, but in kind of a way, you're going to do that, because like a lot of algebra teachers or math teachers in general might cringe at hearing me say distribute, because that's not really the way we should think of that. But in a lot of ways, that's what's happening. All right, so this 3, what you want to do is you want to apply that 3, the power of 3, to everything that is inside the parentheses. Okay, not just what it's closest to everything, to the 4 and to the x. So that's, like I said, it's kind of like distributing, but remember, you didn't hear that from me, but that's kind of what's going on there. So you got 4 to the 3rd power, and then you have x to the 3rd power. Okay, so that's what that means. And then this is probably, I mean, this is not 4 to the 18th power, so we can work this out. 4 to the 3rd power is 4 times 4 times 4. 4 times 4 is, if you can't do it in your head, just write it out. 4 times 4 is 16. And then 16 times 4 is 64. So there you have your simplified solution there. We got 64x cubed. And that's it. Can't do any more with that. Okay. That's it. All right, moving down to number 7. And we're just going to follow what we have been following here, which is we are going to apply that 4 to every single part. Every element of this problem is going to have a power of 4. So we're going to apply it to the numerator. We're going to apply it to the denominator, the 2, and we're going to apply it to the variable, the u. That's it. So I'm going to go ahead and just write it down first. We got 1 to the 4th power. We have 2 to the 4th power, and we have u to the 4th power. And then let's clean that up. All right, now 1 to the 4th power is just 1. It's not 4. It's not 4. It's 1 times 1 times 1, which makes 1, not 4. All right, 2 to the 4th power is 2 times 2 times 2 times 2, which is 16. And then the u, nothing really happens to it. We can just leave it as it is. Okay, so it's 1/16 u to the 4th. So looking at these notes are spread out kind of a weird way. All right, for number 8, we're going to do what we did in the last one. We're going to apply the 3 to everything that's inside the parentheses. And I want you to make a note here in your head, or at least a mental note. The inside number, the base, is a negative. So if I rewrite that, I'm going to write that as -3, kind of like this, -3 cubed, and then I'm going to write g cubed. All right, and so when you look at it that way, then it's more noticeable that you have an odd power. The 3 is odd, and you have a negative base. So if it's an odd power, negative base, that means it's going to be negative. It's going to be negative. So it's going to be -27, because that's what 3 times 3 times 3 is. -27 g cubed. And that's it. That's all you can do with number 8, okay? So I can see, like, as you do more of these, more kind of catches on. But you really do, like when I put some stuff on Alex here, you really want to practice it. And if you're really struggling with them, you can always do that feature where it gives you another one like the problem you just did, or keep working on them, or go on Khan Academy and get some extra practice. But you really do want to kind of have a handle on this. Moving on in algebra, this is one of those, knowing how to work with your exponents is important. Moving forward in algebra, not just in this class, but the next course and further on in math as well. Exponent rules just are everywhere. They just happen. All right, for number 9, we're going to apply that 5 to everything. So we have 2 to the 4th power. Not 2 to the 4th power, not 2 to the 5th power. 2 to the 5th power, and then we're going to have w to the 4th fifth. So that's right there. That's a power to a power. Sometimes some people write p to p, power to a power. Okay, and that means multiply them. So 4 times 5 is 20. 4 times 5, and anything else that we can extra do here is we can just kind of work out 2 to the 5th power. 2 to the 5th power. Now that does not mean 10. It means 2 times 2 times 2 times 2 And I don't have to do this every time I do an exponent, but I just want to make sure you guys know how to work these out. So 2 times 2 is 4, right? And then you're going to multiply. All right, you're going to multiply 4 times 2, which is 8. Okay, and you're going to do 8 times 2, which is 16. Let's see what I'm doing here. And then 16 times 2, which is 1,000,000. No, it's 32. Okay. So that's how it comes to be 32. So you got 32W to the 20th power. And that's right as rain. Okay. Moving on to number 10. All right. Now this front part right here, I think the initial like gut reaction we have to sometimes with problems is to look at this and we see the very front of it. You know, we see that 2 times 8. We're like, oh, 16. I'm gonna write down 16. But your instincts sometimes are not always the best thing to go with. We have to follow order of operations. And order of operations tells us that exponents come before multiplication. So if I do 2 times 8, that's multiplying. But I have to keep in mind there's an exponent. There's an exponent of 2 in that problem. So we want to take care of that first before we do any multiplication. So let's do that first. We got 2 and then 8. I'm just going to go ahead and do that. 8 squared is 64. And then m squared, n squared. So that 2, like I said, that 2 applied to 3 different things. It made the 8 square, it made the m square, and the n as the Nancy square. All right, now we can multiply by that 2 that's in the front of the problem. And 2 times 64 is 128. 128. So you got 128, and then m squared, n squared. Okay, now all I did was multiply this and this. We didn't have to do anything with powers anymore because there was nothing for those powers to interact with. Those powers are only going to interact with another power. Okay, but coefficients can interact, like multiply, add, subtract with other coefficients. Okay. All right, did I do that? I did. Okay, so the next one, property power rule for exponents. And really, we're not doing anything different here. Or what did I say? Power rule for a quotient, not an exponent, but power rule for a quotient is where you have, you know, we just have a fraction in there, and we're just going to apply that exponent, the power part, to every part of the ratio or the fraction. Okay, not just what is closest to it or nearby. We're going to apply it to everything. So this 4, that 3 will apply to the 4, and it'll apply to the denominator as well. So that's what you have. We have 4 to the 3rd power, 5 to the 3rd power. And then we might as well work out the top and the bottom. So the top is 64. 64 and the bottom is 125. And that's in lowest terms. All right, moving on. All right, number 12 is not too tough. Just going to apply that 2. We're going to square everything. So the x is squared and the 6 is squared. So let's just go ahead and finish that right now. X squared and then 6 squared is 36. So you can write it like that. Another way to write it is you might sometimes see it like this, 136, you know, because there's a 1 in here. And you might see the exponent part, you know, the variable, kind of right in the middle there, right in the middle. And sometimes people confuse that with meaning like it applies to both the top and the bottom, and it doesn't. When it's right in the middle there, in line with this vinculum, that line, that division line right there, that it really only applies to the numerator. It does not apply to the denominator as well. I mean, in a way, indirectly it applies to the denominator, but interacting wise, it doesn't really work with the denominator. All right, and number 13 is pretty easy. You're just going to apply that 7 to everything. That's it. So u to the 7th and b to the 7th. That's it. That's all you got to do on that one. All right, I'm going to stop this video. I'm going to do another video for 2.1b. Okay. All right, see you in the next video.